All right, our first lesson on navigation, we're going to go over the basics. These are some of the concepts that are foundational to the next several chapters. So what we're going to go over in this specific lesson is aeronautical charts, how the Earth is divided up by latitude and longitude, time zones and areas where you'll see time zones in your flight planning, variation and deviation. So let's jump right in. So aeronautical charts are going to be a big part of your flight training. They're going to be a big part of your flying from here on out. The major aeronautical charts that we're going to use in our training are the VFR sectional and the terminal area chart. The VFR sectional is in a larger scale than the terminal area chart, as you can see on the screen. And there is a sectional chart for all regions of the United States. So if you were taking a flight to Florida, for example, you could procure sectional charts for Texas, Mississippi, Alabama, Florida to make your trip. The terminal area charts are only available in major metros. There's a handful of them around the United States. Areas like Dallas-Fort Worth, Atlanta, Los Angeles, the major Northeast areas, Philadelphia, New York City, things of that nature. So for those of us that fly around major metros, we tend to use the terminal area chart because due to its scaling, it gives us a lot more detail. There's a third type of chart that we probably will not use as much in our training, but it is available, called the World Aeronautical Chart. It has an even greater scale than the sectional chart, and it covers almost 2 times the area. So as you can see on the screen here, this is a WAC chart, World Aeronautical Chart, encompassing Southeast Texas, Houston area, Louisiana, and New Orleans area, as well as some of the southern parts of Mississippi. So these charts, there's only a handful of them for the United States, but they do cover the entire United States. And for folks that are doing maybe higher altitude or longer trips, this would make more sense for your pilot bag. Let's jump into latitude and longitude. The Earth, which is, of course, a sphere, unless you come from the flat Earth Philosophical Society. The Earth is split into grids. We know them as latitude and longitude. The latitude, of course, travel around the Earth east-west, and lines of longitude travel around the Earth north-south. Now, what's interesting between the two is lines of latitude don't necessarily meet at any point. They traverse the Earth just east-west, slicing the Earth in an up and down fashion, if you will. Lines of longitude, however, do meet at the poles. So you can see in the graphic to the bottom right, lines of longitude will traverse the Earth and will join all at the true North Pole or the true South Pole. And I've got a comment there with an arrow, lines of longitude meeting at what we call true north. So because of that, and this is a very important point, lines of latitude and lines of longitude are all in the true reference system. So some people call it the true reference system or the true north reference system. So if you are drawing course lines on your sectional using lines of latitude and longitude, which are these black tick mark lines that create these square grids, if you're using those to draw your course lines as reference, you're using the true north reference system. And of course, you know, let's use an example here actually. I've got points A and points B. If you're traveling from A to B, you're traveling to the east on the true north reference system. So you're essentially traveling a heading of 090 A to B on the true reference system. Now, it's important, we'll get into in a minute here, but that's with regards to true north. It's not something you can use your aircraft's compass for, because the compass in your airplane is a magnetic compass. It's based on the magnetic reference system, which we'll get into in a minute. But the first step in our flight planning is always to utilize the true north reference system to figure out our true course. Your true course is going to be your course line that you draw with respect to the true north reference system, or with respect to lines of latitude and longitude. Time zones. This is something that everybody probably has experience with from their everyday lives already. Of course, here in Texas, we live in the central time zone. We do participate in daylight savings time. If you're on the coast, on the west coast in California, you're in the Pacific time zone. If you're on the east coast, you're in the Eastern time zone. Depending on where you are in the world, you may be in some other time zone. But time zones come into play primarily during times of daylight savings. That's when you will have the most, I'd say, interaction in your flight planning. And I've got an example here on the screen. When you look at some of the FAA documentation, like this snippet I took from the FAA Charts supplement, formerly known as the Airport Facilities Directory. It's the green book that everybody has. You'll see a cross symbol next to some of the times, and that cross symbol simply denotes that because the location, such as Addison Airport, which is this snippet, because this location participates in daylight savings time, you must subtract an additional hour during those times to get the accurate local time. So for example, today is April 3rd, 2020, and it's after the daylight savings time period. So with respect to Zulu time, time in Texas is 5 hours behind. If I want to get an accurate local time of the tower operations time at Addison Airport, which is 12 to 400 Zulu per this facilities directory, I'm going to have to keep the 5 hour difference that I'm used to with no daylight savings time. Okay, so what that means is the tower will be active from 12 subtract 6, that extra hour which that cross represents, which will be 6 a.m. to 4 subtract 6 to 10 p.m. During times of daylight savings time, we will not subtract that extra hour. We were already 6 hours behind, so it'll again be 6 a.m. to 10 p.m. An easier way to think of this without having to remember whether or not you have to subtract the hour, if it's got a cross, it simply means that daylight savings time does not affect the tower operations time in this example. So whether or not, that's the way I always remember it, whether or not we've got daylight savings time in effect, Addison's tower will always be open from 6 a.m. to 10 p.m. Next, I want to talk about how Earth's magnetic field affects our flight planning. Now, we've already talked a little bit about how during our flight planning, we will use a course guidance based on true north, or what we call the true reference system, and that's lines of latitude and longitude. In fact, you can see lines of latitude and longitude in these maps that I have on the screen. It's the black gridded system that you see on these maps. But Earth, as many of us probably know, has a magnetic field. And our airplanes utilize magnetic compass to navigate around the Earth. We do not use a true compass. We do not use something that has reference to true north. We have a device in the cabin that has reference to magnetic north. And so on this bottom graphic you see over here is the magnetic north reference system. You can see magnetic north, which is the red star, is a good 1,300 nautical miles away from the true North Pole, which is at the top of this picture. And so because the airplane utilizes a magnetic compass with regard to magnetic north, we're going to have to do all of our flight planning in the magnetic reference system. And we'll get into that in a little bit, but basically what you're seeing here in the United States up here in this graphic is our United States is really split down the middle. It kind of splits down through Texas here, with some of the magnetic variation over to the east and some of the magnetic variation over to the west. Those are the red lines versus the blue lines. And magnetic variation is simply the difference or the variation at that specific location between our magnetic reference system and our true reference system. So you could say if you're on this green line splitting down the United States, your magnetic variation is actually 0. If you're off to the right, you've got an easterly magnetic variation, and if you're off to the left here in the red, you've got a westerly magnetic variation. So we're going to use this magnetic variation, which again is the difference between our true north reference system and our magnetic reference system. We're going to use that to convert our true course to our magnetic course so that we can use our magnetic compass in the airplane. Finally, one more item we need to cover as far as our navigation basics is magnetic deviation. I just went through the fact that we need to use our magnetic compass for navigation in the airplane and for all things navigation, whether it's using your radio navs or things of that nature. But before we can do that, once we've converted our true course information to our magnetic course using variation, which I just went through, we need to take one more step and account for the fact that the avionics in the airplane create an electrical disturbance that affects your magnetic compass. Any sort of electronic radio or navigation source or anything with a battery or an electric charge is going to create an invisible current in the cabin. We call this electromagnetic deviation. And so that has to be taken into account when using our compass, and we do that through use of a compass card. I've got a picture of that on the screen. On the bottom part of this compass, you see the person that installed the compass, the mechanic that put the compass in the aircraft, did a deviation study with the avionics and determined that if you're going to fly some of these directions, for example, 30 degrees, if we're going to fly to the northeast at a heading of 030, you're going to actually have to steer 1 degree to the right for it to actually be an accurate magnetic direction. Otherwise, if you fly at a heading of 030 on your compass, you're actually, as far as magnetic course on Earth is concerned, you're actually flying a heading of 029. So we will take this into account during our flight planning as well. After once we convert our course line from true to magnetic, we'll then add our deviation factor in to get what's called a compass heading.